Hello and welcome back. Today we are starting a new unit in this series on one of the most, if not the most important data structure in our computer science, namely hash tables. In Python, the two main implementations of hash table are dict and set, and compared to other languages, their simplicity and user friendliness and flexibility are one of the biggest reasons, I believe, as to why Python is such a popular and successful programming language. Enough selling for now, so without further ado, let's get right into the recipe. And for this recipe, the problem statement is quite simple. We are going to see a very high level overview of dict and set in Python. So first, let's see how to create an empty dict. To create an empty dict, you either call the dict method or this construct, and you're going to get an empty dictionary. For set, you just call the set method and you're getting an empty set. And to see some of the attributes of a dictionary object, you just call the D method, and you can see here printed all the methods associated with the dictionary. The most important one are contains, which is what the in operator uses under the root for a dictionary. Same thing for set, and for the case of dict, some of the most important ones are get, items, keys, and values, which you're going to see used all the time. And for the case of a set, one of the most important one is add, to add something to the set. Union, all the set theory method, intersection, symmetric difference, all these are very important for the case of set. We're going to see them later on in much more details. And the second item for this recipe is keys. What are keys? Well, before saying what they are, we need to define a bit more in details what is a hash table. A hash table, generally speaking, is a container that maps a key to a value. A key to a value. So, for example, for the case of sequential containers, we don't have a notion of a key because values are accessed via their position in the container. So, if you create a list, if you want to get the value at position 1, you do the list brackets 0, because list in Python are indexed starting from 0, so you get the item at that position. Well, for the case of hash tables, you have the key, so the way to access the value at a given in the hash table, you need to have the key for that value. In order to insert, you need a key. In order to delete, you need a key. In order to access, you need a key. So that key is very important, and that key needs to respect some characteristics, namely being hashable. Being hashable. So in order to see that, we have here 3 types of keys, and as a general rule of thumb, as long as the object that you are trying to use as a key to your dictionary or your set is a hashable, is a immutable object, then it can be used as a key. If it's mutable, like the case for list, then you cannot use it as a key for a hash table. And you can see here all these 3 are fine, because using the hash method, we can easily hash them to get the position, the internal address where the value associated with all these 3 keys is going to be stored at. And you can see, because all these 3 types are immutable types, the hash function doesn't complain. But for list, because list is a mutable type, when you call hash on a list, Python complains. That's what this exception means here. On hashable type list, because this is a mutable object. So the second item, the second bullet point, discussion point we want to discuss in this recipe is insertion within a dictionary. So like we said, in order to insert in a dictionary, you need a key and a value. And that key, like we saw in the previous section, has to be hashable. And the value doesn't need to respect anything, it's just any type of object. You can even map a key to another dictionary, that's very fine. So here we map key to value, and so on and so forth. And when we print the dictionary, you can see internally how it looks. So you have the key the string key pointing to the string value. It doesn't have to be, but that's what we did, that's what we created here. And you see the int key pointing to an int value here, which is a string again. And you see the tuple, which is perfectly hashable because tuple are immutable, pointing to another value. And if you print the keys, you can print the keys, you can print the values, and you can print both the keys and the values using the item method. For the case of a set, you can add an item within your set using the add method, and that's it, nothing more than that. And to explain the difference, what's the difference between set and dict? A set, this is another simplification, but a set can be seen as a dictionary with keys pointing to nothing. So if you want all the advantages of dictionary, namely constant time access, constant time edit, constant time deletion, but you don't need to have values associated to your keys, then you better use a set instead of a dictionary. And you can that's why here, when we are adding to a set, we are not associating any value because we don't have anything to associate to the set. What about lookup? I said earlier that both dictionaries and set under the hood, when you call the in operator, is going to use the underscore contains method that we saw here, both for dict and set. And when you do in like this under the cover, that underscore contains method is being used to test if this key is within the dictionary in constant time. Once again, same thing for here. That's why you can see all these three are returning true. Same thing for the case of a set. But when you test if something that is not in the dictionary is not in the dictionary, you get false. And all this is happening in constant time, as you will see the benchmark in the final section of this recipe. So what about deletion? Well, when you call the del method, the del literal like this, you pass in the key to tell Python what is the key that you want to delete from the dictionary. When you print your dictionary back, you see that the key has been deleted. So you remember we had one item, the key 1 in our dictionary earlier on, but when after calling this, running this snippet, now the key is no more there. Well, you can use either del like this, or you can use pop, which has some nuance that we are going to discuss. Well, we have already deleted 1 here, so when I'm calling 1 again like this, trying to delete it using now this time the pop method, 1 is no more there. But the pop methods allows you to get a value, an optional returned value, in the case where the key that you're trying to delete is no more in the dictionary, which is why here when we print the second result, we get optional res if key not found as return value. Whereas let's do the same for a key that is still in the dictionary, namely the key called key. If we do it again, remember, key at this time before running this, key is pointing to str value. So after doing that, we want to pop this key from the dictionary, and the pop will return us. What it will do, it will remove both the key and the value, but it will return to us the value. It will remove them from the dictionary, but it will give us back the actual value that was referenced by that key prior to it being deleted, and that's what you get here. But what if you do pop key for a key that is no more in the dictionary without providing an alternative value in the case the key is not found? Well, this will raise an exception saying that this key is not in the dictionary. That's what you see here. Key error, key is not in the dictionary anymore. That's why you get this exception. What about deletion in set? Well, for the case of set, you have the remove method. So if you know the key that you want to remove from the dictionary, from the set, sorry, you call the remove method, and that key is going to be removed. So here, after calling this code, the key 1 has been removed from the set. What if you don't care, you just want to remove any key from the set? Well, you just call the pop method without passing anything as parameter to the set, and a key at random will be removed from the set. In this case, the tuple key was removed. What about calling the pop method and passing an attribute? Well, that's not how the pop method, unlike the pop method for dictionary, has been implemented for set. So pop method for the case of set expects nothing as parameter. It just deletes something at random. If you know the key that you want to delete, you better use the remove function, because otherwise you're gonna get an exception, and that's what Python is saying here. Pop takes no argument, but you have given one. So be careful about this little nuance. Dictionary pop method is very different functionally to the set pop method. So what about set and dict comprehension? Well, like we saw for the case of sequential containers like list and tuples, we also have set and dict comprehension in Python. So here we are constructing a dictionary, both with this initialization or this dict comprehension, and you can see D1 and D2 are exactly the same, just apart from the fact that they have been constructed in different ways. This way is a bit longer, you will say, but if you need more flexibility, for example, you need to construct, for example, let's say for the case of D3, we just want the keys that are not equal to B, then this syntax, which is the dict comprehension, allows you to do that. You can filter either by keys or by values. So you can also say, I don't want, for example, for the case of D4, I don't want in my final dictionary to contain any key pointing to a value that is less than 2. And that's why here in D4 we have everything that is in D1 except for the key A, which is pointing to a value which is 1 lower than 2. So same thing, you have set comprehension as well. Same idea, you can filter on the keys like this to get more flexibility. So yes, that's it for the set and dict comprehension. And finally, one of the biggest difference between list and sequential containers and hash table containers is the performance. So like we said, hash tables are one of the most important data structure in computer science because they give us constant time access or updates or deletion to our hash tables. Let's see this by doing a benchmark between a list with 10 million elements, a dictionary with 10 million elements, and a set with 10 million elements. So when we call the in operator in a list to test if something is within the list, this is the time it takes. It takes 637 milliseconds to test if the latest element in this list is within the list. Whereas for the case of a dictionary or for the case of a set, it takes almost 250 microseconds, which is tremendously faster. So this is one of the reasons why dictionaries and set are one of the most important data structure, because they allow you to do things in constant time. So that's it for this recipe. Hopefully you learned something new. If the case, please give it a thumbs up. Also feel free to ask any question in the comment section down below. I will do my best to answer those. As always, you can find the link to the code in the description. Be sure to subscribe for future videos, and thanks for watching.